The war between SQL and NoSQL is something that we probably drag on as long as the software development community exists. Every single developer has where they stand when it comes to this particular topic. This is because both types of databases comes with their own drawbacks and benefits. Take SQL for example. It is an ANSI and ISO standard language. SQL provides a universal method for interacting with relational databases across different platforms and different database management systems. It utilizes straightforward English-like commands, making it relatively easy to learn and use, even for individuals without extensive programming backgrounds. Why NoSQL offers flexible, dynamic, or schema-less data models, making them suitable for applications with rapidly changing data requirements or unpredictable data types. They can store and manage diverse data types, including unstructured, semi-structured, and complex data, allowing data to be stored in ways closer to how applications use it. One of such NoSQL databases is MongoDB, which will be the database we will be looking at today. Since we have agreed that they are both good for different purposes, in today's video, I will introduce and familiarize you with how to get started using MongoDB with Go. I will show you how to set up a development environment for MongoDB using Go. I will show you how to connect to your MongoDB database from your Go development environment. I will show you how to create records. I will show you how to fetch records. I will show you how to update records. And finally, I will show you how to delete records. So if that makes sense to you, then absolutely smash that like button and ensure you subscribe to the channel to get access to all of our videos as they drop. I will create a new file named index.go, and then I'm going to open up a terminal to run go mod init mongodb underscore animal underscore app, and after that I will create a simple Go program by first declaring a package main, and then I'm going to import the fmt module from the Go standard library. I will declare a main function, and inside it I'm going to call fmt.println Go with MongoDB, and then I'm going to run go run index.go from the terminal to start up the app, and you will see a string in our terminal go with MongoDB. Now let's proceed to the actual application we have to code for today. I will create a new file named package/helper.go, and inside this file I will declare a package helper. I will import context from the Go standard library. Then I will declare a new type animal, which is a struct. It will have a name property, which is a string, a habitat property, which is also a string, and a movement property, which is a string. Forgive my use of lowercase for the habitat and movement property. I will fix this as we progress. Next, I will declare a function connect, which accepts two arguments, URL, which is a string, and DB, which is also a string. The function will return two values. The type of the first value will be a pointer to a MongoDB.database, while the second will be an error object. The responsibility of this function is to allow us to connect to a MongoDB database. Inside this function, I will create a new variable client options, which is equal to the result of calling the options.client.apply URI with the URL as the argument to the apply URI function. Next, I will call mongo.connect, passing a call to context to do as the first argument to the connect function. The client options becomes the second argument. I will store the return value from this operation inside two separate variables, client and error. I will check if there's any error while trying to connect to the database. Then I'm going to return nil as the first value, while the error becomes the second object. Then I will call client.ping to make a ping to the database. I will also retrieve the error from this operation and store it inside the error variable. I will check if there's an error and then return nil as the first value, while the second value returned will be the error object. Lastly, if everything goes according to plan, which rarely happens, then I return a call to the client.database, passing in the DB argument as the first return value from the function. Lastly, if everything goes according to plan, which rarely happens, I will return a call to client.database, passing in the DB argument to it. This will be the first return value from the function, while nil will become the second return value from the function. Ensure to run go get go.mongodb.org/mongo-driver/mongo. You also have to run go get go.mongodb.org/mongo-driver/options, and finally you also have to run go get go.mongodb.org/mongo-driver/bson. This is to install the correct packages that is going to allow MongoDB work with this application that we are building. I will head back to the index.go file, and inside this file, I'm going to import the helper package we just declared. Then in the main function, I will call helper.connect with the link to my local MongoDB database. The name of the database we are trying to connect to is going to be test, and then I will store the values returned from this into two separate values. The first, which I named collection, while the second is error. I will check if there are any errors while trying to connect to the database, and then I will call log.filter with that error. If there are no errors, I will just print a message to the console connected to the database. I will start up my local MongoDB database, and then I will run go run index.go from the terminal. And you can observe that we get the results that we have connected to the database inside of the terminal. I'll head back to the package/helper file where I will define a new function, create trainer. This is supposed to be create animal, but only me and God knows why I named this function create trainer. This function is supposed to allow us to create a single record in the database. This function accepts two arguments: collection, which is a pointer to a mongo.collection, while the second argument will be a struct animal. And this function will return two values. The first one will be of type mongo.insert1result, while the second one will be an error object. Inside the function, I will call collection.insert1 with context to do as the first argument, and then the animal struct we want to add to the database will be the second argument. I will store the return values into two variables, insert results and error. I will check if there are any errors while trying to create that record, and then I'm going to return nil followed by that error. If there are no errors, I return the insert result followed by new. Let's head back to the index.go file to use this function to create a new record in the database. I will create a new animal goat whose name is goat. The habitat will be land and the movement will be run. Then I will attempt to add this animal to the database and print out a message to the console: record added successfully with insert results.inserted id. And then I will run go run index.go from the terminal. I can observe that that record has been added successfully to the database. Now, I didn't handle the error here. You know how we handle errors in our Go application, and you should also do that, especially in a production environment. Okay, now let's try to create multiple records. First, I will create two new animals, cow and chicken. Then I will head back to the package/helper.go file, and inside this file, I will create a new function, create multiple trainers. This function will accept two arguments. The first one is the Mongo collection to query, while the second one is an array of trainers. Only God really knows what I have with trainers. The function will return two values. The first one will be a mongo.insert results, while the second one will be an error object. Inside this function, I will call collection.insert_many with context.todo as the first argument and the trainers array as the second argument. I will check if there are any errors encountered while trying to create multiple records, and then I return nil as the first value from this function and the error as the second value. If there are no errors, then I will return the insert_many result as the first return value and nil as the second return value. Then I will head back to the index.go file where I will create a new array, animals, and I will add the cow and chicken inside of this array. Then I will use this array to create multiple animals inside the animal collection. If there are any errors encountered while trying to create multiple animals, I'm going to log it out to the console, and if there are no errors, I'm going to call fmt.printf with records inserted successfully with the length of the inserted animals. Then I will run the app for the terminal, and you can see that we have two records inserted successfully in the terminal. Now let's see how we can fetch multiple records from the database. I will head back to the package/index.go file where I will implement a new function, fetch all animals. This function will accept two arguments. The first one is the collection we want to query, while the next argument will be an array of trainers. Again, trainers instead of animals. What is really wrong with us today with trainers? Anyway, the function will return an array of records and an error object. Inside the function, I will create an empty filter object using the bc.m interface, and then I will call collection.find with context.todo and the filter object. This will return a cursor and an error object. I will process the error if there are any, and then I will defer a call to cursor.close with context.todo. Then I'm going to call cursor.or with the same context.todo, And thank God I have renamed the trainer's argument to animals at this point. I will pass a pointer to the animals array as a second argument to the console or function. If there are any errors while trying to unmasher the documents into the animals array, I will return nil and the error. If there are no errors, I will return the result and nil from the function. I will head back to the index.go file, delete most of the existing code. The animals array will be an empty array. Then I will make a call to helper.fetch all animals, and I will console log the length of the array returned attached to the text. You can see that we have 5 records inserted successfully. This is supposed to be retrieved, not inserted, because remember, we are not inserting again, we are retrieving. Now, let's see how we can fetch a single record using the ID of the record. I will head back to the packages/helper.go file, where I will add a new function, fetch animals by ID, which accepts 3 arguments. The first is the collection we want to query, while the second will be the ID of the document, and it will be a string. The last argument will be an interface of an animal. This function will return an interface as its first argument and an error object as the second argument. Inside the function, I will create a filter using BSON.m. The object will have an underscore ID property, which is equal to the ID argument we pass into the function. Then I will call collection.findOne with context.todo and the filter. Then I'm going to chain a call to the decode function with a pointer to the animal argument. If there are any errors, I will deal with it as usual, and if there are no errors, I return the animal and nil. I will head back to the index.go file, where I will create a new variable, new ID, which is equal to the result of calling primitive.objectID from hex with the ID of the document we want to retrieve. If there are any errors while trying to construct that object ID, I will log it out to the console. Then I will use the new ID to retrieve the document whose ID matches the one we passed in. I will create a variable animal, which is of type helper.animal. We'll also pass this into the helper.fetchAnimals by ID function. Then we will log out any errors encountered while trying to fetch the animal to the console. And after that, I will log out the animal to the console. Now let's see how we can update a record. I will head back to the package/helper.go file, where I will add a new function, update animal. This function accepts 3 arguments. The first is the collection we want to query. The next is the filter we want to use in querying the collection. And the last one is the values we want to update in the document when we find it. I will return a mongo.update results and an error object from this function. And inside this function, I will use the filter and the updates to find and update the document by calling the update1 method on the collection. If there are any errors while trying to update the document, I will return it from the function. Otherwise, I will return the update result and nil from the function. I will head back to the index.go file, where I will create a variable filter which is of type bson.m. Basically, this is targeting the animal with the name of goat, and I will change the movement type to hop. Then I will call the update animal method on the helper package, logging out any errors encountered to the console and printing the result to the terminal, which we can see. And last but not the least, let's head back to the package.helper file to see how we can delete a record. I will add a new function, delete animal, and this function will accept 2 arguments, the collection we want to query and the ID of the document we want to delete. I will return a boolean and an error object from this function. Inside the function, I will create a filter to get the ID of the document using bson.m. Then I will call collection.delete1 to delete the record using the filter we pass into the function. I will return any errors encountered from the function, and if there are no errors, I will return true from the function and nil. I'm going to let you figure out how to consume this function to delete a record inside of the index.go file, and that should be very easy if you've been paying attention to this video. Anyway, if you enjoyed this one, then absolutely smash the like button. Ensure you subscribe to the channel and turn on the bell notification, and I'm going to see you in the next one.